Welcome everyone. I am Harpreet Singh from DSA Batch 6 and today I will be contributing to Google Winter of Contributing um, by the today's topic, that is operations on doubly linked list insertion. So without any further ado, let us look at the concept. So before starting the cases of insertion, let me first discuss what is a node in a doubly linked list. So the node here will be containing three things. As in the single linked list, it contains only two things, that were data and next pointer. But now, in this case of doubly linked list, the speciality which is coming here is it will be containing a previous pointer as well, which will be used to point to the previous node. Okay, and next we know that it points to the next node, and data we know that it contains a data. And okay, so let us see, and the collection of these nodes will be a doubly linked list. Yeah, so here we have got a doubly linked list where head will be pointing to the first node, and the first node's previous will be null, and the last node's next pointer will be null. So this is a doubly linked list. Okay, so let us look at the three cases of insertion in doubly linked list. That is, the first one is insertion at the beginning, second one is insertion at the last, third one is insertion at an index. So let us look at it by one and carefully examine that what will be the concept used here. Okay, the first one is insertion at the beginning. So we are already having a doubly linked list, and we will be having a new node. We will be creating a new node which I wanted to add at the first index, basically at the zeroth index at the starting of the doubly linked list. So how can I do that? Um, First of all, I need to check if my head is null, that is, it is not pointing to any node. Then my head as well as tail will point to the new node. That's it. Uh, if it is not the case that head is not null and we are already having a doubly linked list and head is pointing to a node already, then what we need to do is, first of all, we will say that head's previous, like this A is previous, will point to the new node. Fine. Then what I will do is, new nodes next will start pointing to head. Start pointing to head. That is E's next will be pointing to A. Okay. After that, what we will be doing is, head will stop pointing to the uh, earlier first node and it will start pointing to the new node. So what will be the concept here? Head will start pointing to new node and its next is pointing to A's previous is pointing to E. Then we can say that the insertion at the beginning has been successful, and our traversing, if we will traverse, it will start from E, not A. So this was insertion at the beginning. I hope it is clear. Now let us see the insertion at the last case. So insertion at the last is, I am already having a doubly linked list. I need to insert the node at the end. So what I can do is, I will traverse till I get the last node in the doubly linked list, and once I will be getting the last node, then what I will be doing is, its next, I will make it point to the new node, that is the new node, and in its new node's previous, I will make it point to the pointer which I will be having, that is on this current. Suppose I am having a current pointer here, so in its previous I will be making it point to this. Yeah, and if it will be done, then what I can do is, I will make the tail also point to the newly created node, not the previous one. So insertion at the last will also be successful like this. Now let us look at the last case, that is a crucial case, that is insertion at an index. Okay, so for this we should handle, first of all, if the index is 0, then it is the insertion at the beginning case, and if the index is the size of the linked list, like in this we are having 0 1 2 3, if I give the index as 4, I need to insert a node at 4, then it is a case of insertion at the last. So we should handle that accordingly, respectively, because its functions will be made accordingly, and when I will show the code, you will better understand that. Okay, So now what we need to do here is uh, I will be getting an index. Let us suppose it is at the 0th index, first index, it is at the second index. So suppose in this example, I need to add a node at the second index. So what I will be doing is, let us look at it carefully. I will be having a new node. Okay, so I will traverse till I get the node of the specified index. Like if I have given the index 2, then I will be going and traversing till this node till I get this index node, second index node. So suppose a pointer forward is pointing to C, and I need to add E between B and C. So I need to break these two links and I need to attach these links like this. So how it will be done is, let us see. Okay, so what we'll be doing is in the new nodes next, we will be making it point to forward, right? And in forwards previous next, it will be new node. Then um, in forward previous next, it will be new node, and the previous of the new node will be forwards previous. So this link will also be attached, and in forwards previous, I can attach the new node, and in the new nodes next, we were attaching the forward. So like this, these two links will be broken down and these four links will be made, and we just need to look at the order in which we do it. The order we are following must be taken care when we are accessing the previous node. So in its previous, I should um, morally assign the previous of this actually existing node to the new node uh, at the last, right? Rest of the things, I think it can be in any order, it will not matter. We need to basically do dry run before writing the code. We should not rote learn these things. We should apply the concept there, like what will be the case, what will be the scenario, and accordingly we should write the code. Okay, so this was the last case, that is insertion at an index. Okay, so let me talk about the complexity analysis. If we are inserting at the beginning, then it is taking order of one time because we are not traversing the linked list and we are just inserting at the 0th index. When we are doing the insertion at last, so it will take order of one time if we are having a tail pointer, otherwise it will take order of n time, otherwise it will take order of n time, right? Order of n time, fine. And if we are inserting at an index, then it takes order of one time for the best case, like if we insert just in the starting itself. But if we are inserting till the length, we need to traverse more, then in the worst case its time will be order of n. So basically it depends on the traversing, how much we traverse. If we traverse less, it will be constant time. If we traverse the equal to the length of the linked list, then it will be order of n time. If we talk about the space complexity, then for insertion and doubly linked list, it is constant time, that is order of 1, because we are just having a new node that is being created and it will be done uh, with a constant space complexity. Okay, so now um, let us look at the menu driven program that I have created so that you can get a better understanding. Okay, so first of all, we can import all the packages like this in Java. Then I'm having a class name same as the file name because that is the thing that we need to follow in Java. And I'm declaring this input taking thing as public static so that I can use it anywhere I want to. This is a good practice to do like this because I will not be uh, using this line in all the functions. So I can just make it public static so that I can use it anywhere I want to. Okay, so we are creating here a class of doubly linked list. Okay, we are creating here a class of doubly linked list which will be containing all the things that a doubly linked list should have. So first of all, I will create a node. in this public doubly linked list, I am creating a private type node. Why? Because I don't want any client to visit this node, to access this node. If he or she will be able to access my node, then they can change the data, they can change the previous pointer, they can change the next pointer, so my linked list will be corrupted. So for that purposes we should make it private. Okay, like from the main function also I will not be able to access the node, but within the functions I can access it, right? So we were having three things: data, previous pointer, and next pointer, right? Then we are having a constructor. If it will receive data, we will update the data. Okay, then we are having outside this class, outside this class node, in the class doubly linked list only, we are having the head pointer, that is null, that will also be private, tail pointer, that will also be null, and the size that we are maintaining. So this is a function toString. This is not a conception to write, this is not a compulsion to write, but it is a good practice to write it. What we are doing here is we are having a string builder, and I am having a current node starting at the head. I am appending in the string builder the square parenthesis. Then while this current is not equal to null, I will be traversing basically till the last of the linked list one by one. So I am getting here the first node, suppose. So I am adding it in the string builder, the data of the first current node. Then if its next is not null, then I am appending the comma as well with a space. Why I am doing so? Because in the end, when current next will be null, we don't want to add this comma, right? And current should be equal to current next, so that I can traverse more and more ahead. And in the end, I should append the closing brackets, and from here string builder should be written as a string. Okay, so basically this is a function toString that will override the Java's already written toString, and it will show me the content of the doubly linked list in a good manner. So basically, to display the doubly linked list nicely, we are using this. Okay, so we are having some exceptions as well. We are doing exception handling. If the index is invalid, exception, then I am receiving the index here, left range and right range. So if index is less than this left range and index is greater than right range, or basically in between, then I just need to say that index is invalid, and invalid will say if it's true, it's invalid. And if it is not invalid, then it will return false, as it will not go into the if statement. The basic function I am having here is to return an integer type size that I am maintaining, this dot size, and I will be checking here is empty as well, which will say that this dot size equal to 0, then return true. If it is not the case, then return false. Okay, so these were the basic functions that we were dealing with. Now let us talk about the real context, which is this video all about. So that is the insert functions. So the first one is insert first node. So I am receiving it is a void type, it will not return anything. It is receiving a node type, node pointer. Okay, so basically this is a node that is a new node that I need to add in already existing doubly linked list. So if the size is 0, I have discussed the case, head and tail will point to the new node, and in the new nodes next we will be pointing to the head. In heads previous we should assign this new node, and head will be now pointing to the new node, right? And we will increase the size by 1. This is insertion at the first private type function, which we are calling with the public type function, where we are receiving the integer type value. Okay, so we are making a node type node. We are creating a new node with this constructor and passing the value so that its value will be updated in the data private variable, and we are just calling a private function. So basically what I am doing here is these are the oops concept that we should use. Like this, we can just only pass the value, and all these type of things will be private, so that the user cannot change these things, right? Similarly, for this thing, insertion at last, I'm calling the insert last node function. yeah, basically if the size is 0, then you should consider the um, that case only, like head and tail should point to the node. Otherwise, what I need to do is, yeah, I will be having two options. First one is I can just traverse the whole linked list and do the thing. Otherwise, I'm just having the tail pointer. And it's next we will attach the new node. In nodes, previous will attach the tail, and our new tail will become the node. So this will be done in constant time. Basically, if we are maintaining a tail node, so tail pointer. So it's a nice thing to have a tail pointer, so that its complexity will reduce to constant and size plus plus. Then we are having insert at the index node. Where what we'll be doing is, if my, yeah, here we need to handle some cases. Yeah, from yeah, so basically from here, insert at an index node, I will be receiving an index and data. First of all, I will check index is invalid exception, the function that I have already discussed. It will pass the index, the left range is 0, the right range is this dot size. So basically, if the index is less than 0 and greater than this size, any case is valid, then it will return with true. And if it is true, then I will say print -1 and return from here. Otherwise, if it returns false here, it will not go into this if, it will come into else, and I will be creating a new node with the data, and I will be calling my private function insert at. Okay, so what I am doing here is, if my index is 0, then I should go for insert first of data, that is the case 1. If my index is equal to this third size, then I should go to the insert last function, that is the case number 2. But if it is not the case, then let us talk about the case 3. That is the crucial part. I will be having a forward node pointing to the head. I will be having a count 0. While my count is less than index, I should increase the count and forward should point to first next. So what it will do is, suppose I am having it, I need to insert a node at 2. So what it will do is 0, at 0 count, it will go to the first node. It will go to the first node. At 1 count, it will go to the second node. And when the count will become 2, it will not proceed further. So basically, my pointer will pointing to the exact location for which the index has been passed. And for that case, what we are doing is, we are having a node current. I'm having a node current at forwards previous, so that I should not write forward previous again and again. I am having a current pointer so that I can use it. Okay, so basically if I show from here, current is pointing to B, forward is pointing to C, and new node is here E. Okay, so new nodes next will be forward, that we have already discussed. New node next will be forward previous will be new node. Two links have been attached from here, and then currents next will be the new node, and new node's previous is current, and increase the size, and you are done with this. So we're done with all the cases. Let me tell you the main function as well. What you can do is, for the doubly linked list type, you can make an object of this class, and you can just simply use its functions, but public functions, easily from here. You can just make a menu driven like program. This is a basic thing. I think I should not explain it. This is a basic thing. I think you will be able to get it. I'm having do while do, and if ch is equal to 5 already given as a default value, I'm having a menu. Whatever you want to do, you can perform, and I'm receiving the input, whatever you give the input from these options, and I'm in a switch for that. Whatever you have given to me, according to that, I will be calling the respective functions and asking for you the values that are needed for that. Like in this first and second case, I just need the elements because it is insertion at beginning, insertion at last. In the third case, I just not only need the element, I need to have an index as well where you want to insert. Accordingly, I can pass. And this case is to yeah, if you if you only say DLL, if you will only print the object of the doubly linked list type, then it will call my toString function that I have shown you, toString function, and with the help of that, it will show me the linked list. And in the default case, I'll just say that exit this while loop, and I'm executing this while true. So basically, while true, you will say that might it can be going to infinite loop. No, if you will say any other value other than 1 2 3 4, then with this default case it will exit the while loop, do while loop, and will be out of the program. Okay, so let me execute this for you. Yeah, so this is here is the menu displayed. I can say 1 is my choice, so I need to enter element. I have suppose 10. So if I want to display the linked list, I am having 10 in the linked list. Okay, insert at the last, and I suppose I need to add 20. Okay, 20. Display the node. Then 20 has been added to last. Let me add insertion at the beginning again. 30. So if you see, 30 will be added in the front. Okay, now let me add 40 at the first index between 30 and 10. What will happen? Let us see. At the first index, add 40 and display the linked list. You can see the 40 has been inserted between 30 and 10. So our program is executing nicely. And if we are done with executing all the things, we can just exit and get out of the program. Okay. So thank you so much for um, watching my video so patiently. The references has been taken from Geeks for Geeks, basically the images and all that stuff. And I hope that you have enjoyed the video. If you have any doubt, you can just post a comment in the comment section. Thank you very much.